Hello, I'm Joe Kizis, President of Bravada Gold Corporation. Today I'd like to talk about another project that we have developed some very exciting drill targets, and it's called the East Manhattan Project. It's gold-silver, low sulfidation system. It's located in the Walker Lane Gold Belt, which is one of the three major gold belts of Nevada. There are two gold events in this part of Nevada. The older one, around 25 million years old, is associated with large volcanic features called calderas around the margins, and that includes the giant Round Mountain mine that's in production right now, Gold Hill mine farther to the north, and mineralization to the south at our East Manhattan project is associated with the south end of the Manhattan caldera. But the mineralization there has been dated as being quite a bit younger, so it seems to be using some of the same geologic features, but is a distinctly younger event, more the age of Midas and some of the mineralization along the northern Nevada Rift. The district itself has produced around 1 million ounces of gold. About half of that is placer deposits that have formed due to erosion of some of these high-grade gold veins, and then about half of that is from two open pits that were originally mined by Echo Bay Mining. In this slide we see the caldera boundary here as noted by that black dashed line, volcanics to the north and basement rocks to the south. There are a number of veins that have been historically mined, you can see from the photographs on the left, and our original interest in the project was as a submission from Newcrest. We did some surface sampling, some of the veins, and as you can see there, 3 meters of 23.8 grams. We're pretty excited with the results. Their target was a disseminated type mineralization similar to Round Mountain. We looked at it and thought there's probably more of a Midas style of mineralization here, and that was certainly borne out by our samples. You can see in blue the original claim block. We added a few claims to the east. After mapping the veins in detail, we developed some drill targets, which we drilled in 2008. And so you can see we had some very encouraging results. Our EM10, which is very close to the western boundary with the Kinross claims, we intersected 14 meters of nearly 3 grams, and below that an additional 14 meters of 0.8 grams. Also, our hole number 2 and 3 were pretty exciting. They're on a different vein that does connect up with the others. Now, we are going uphill as you go to the west, and so some of those veins don't actually extend up to the elevation that's exposed on the western edge of the property. In 2011, we drilled some follow-up core holes, helped to define some of the geometry of the veins. And from that work, we concluded that the master vein was actually the farthest north of the east-west veins. It dips to the south. Most of the other veins dip into that feature, which makes for a very interesting target. It's noted here on this map as the master vein. Subsequent to our drilling, then we did some detailed ground magnetics, and what you see here is the reduced pull. This slide shows our interpretation, and in particular the magnetic lows that are highlighted there in the circled areas, the deep blue, are particularly interesting. These are typically formed when magnetic minerals are destroyed by strong alteration, and you can see that they form near and adjacent to the master fault. So very interesting target. In this slide, I've shown some historic soil geochemistry. Particularly the master fault shows up, very strong mineralization along that. The northeast trending features are pretty interesting because they all bleed into the master fault. So those are the colored features there, blue, green, and red in the center. So following the master fault to the east, we see that it goes under alluvial cover and there's no real signature in the soil geochemistry. I also show two cross sections, BB prime along the western edge of the property and AA prime, which actually goes right through the center of the mineralization, the veins, and then underneath the alluvial covered area. Cross-section BB prime is looking west, but it's located on the western end of the property. So this is the highest elevation that we have of the exposure of the veins. They typically have not got very high gold values. There is some anomalous gold, but not very impressive considering that just a slightly down dip on these veins. There is quite a large zone, one of our best drill holes. So this shows something that is pretty common in dip-slip vein systems, and that is that the mineralized shoots tend to be horizontal. In other words, they are stronger as you go along strike. Typically, though, as you go down dip, there are multiple areas where you get these flat-lying shoots. All right, so we know we have one flexure with significant mineralization, good grade, and of good thickness. So where else might we find even larger mineralization, a larger pot of mineralization? And the obvious target there is the unconformity with the Paleozoic metasediments. They react very differently to the stresses of a fault system that's forming, basically along the master fault. And there are a number of examples worldwide, and including very close by at the Midway deposit, which is only located several kilometers to the south and west, several tens of kilometers, I should say. So the obvious target would be to drill the intersection of the master vein with the unconformity at the Paleozoic interface. Now we step farther to the east, same view looking west, and we look at the same master vein set, which is basically not exposed at the surface because it's covered by the younger gravel basin that's formed. The vein that we did drill is farther to the west, and it dips towards the master vein. This vein does not crop out at the surface. It didn't even come up to the surface farther to the east, but does crop out in this area, and there's some decent grades. The intercepts that we drilled in our holes were fairly encouraging at the same slightly lower elevation than what we saw in our first section to the west on section BB prime. Now, if you follow that slightly plunging mineralization, flat-lying shoot even farther to the east, that actually crops out, and that's where we had our best mineralization in our surface sampling. So there does seem to be this elevational control on the uppermost zone. This is one of my favorite targets. This is the confluence of three important mineral controls: the master vein, a subsidiary vein that projects into it that also carries decent mineralization, and the unconformity. The first hole I drill would be the shallow angle hole that would identify the master vein location underneath the gravel cover. We're just projecting it. We don't know exactly where it's located, but it would intersect the vein at about the same elevation that the strong mineralization occurs along the first cross section BB prime, and also in the satellite vein on this cross section. So once that's identified, then the second deeper hole can test the confluence of the three different structures where they intersect, and that should be a very good hole indeed.